This is the Module 10 review, so you can pause the video and copy this stuff down. These are typically always going to be the things that are asked for as well in a circle, but you want to make sure they're really apparent when you graph them, that it's obvious where these things are. This whole unit, we have learned about 3 different conic sections: circles, ellipses, and hyperbolas. You need to know how to graph each one and how to put each one in standard form as an equation. Okay, so here's the important information. We're going to graph each one to start. So being able to identify what each one is. So I'm actually going to change this one, you guys. Yeah, I'm going to change this one. I'm going to make this plus so that this is a circle. Okay, so circle, this one is an ellipse. It's got addition in between. It's equal to 1. This is a hyperbola. It's got subtraction in between and it's equal to 1. So this is my r squared here. So r is 25. My center is at -1, 3. R is 5. Okay, so we're gonna graph that. So we got -1, 3, radius of 5. And again, I just try and do that all 4 directions. And then try and make it look as circular or as round as you can. But again, I have clearly marked where my center is, but if you want to even add in here r equals 5, so we can clearly see that, and then label this point -1, 3. So I actually almost prefer you guys not to do this, but instead do it off to the side so it's easier to read and doesn't crowd your graph. Either way is okay, but this is a lot easier to see. Okay, this is an ellipse. This one, okay, this is b squared and this is a squared, right? For an ellipse, a squared is always the bigger one. Because the bigger one's under y, it's oriented vertically. Okay, so my center is at -3, 1. We have A is 4, B is 2. All right, so graph my center. We've got -3, 1. A is 4, it's oriented vertically, so I'm gonna go up 4 and down 4. And then my B is 2, so I'm going to go right 2 and left 2 from the center. Again, try and make it look round, not too much of a diamond shape or a Stewie's head shape. Okay, so again here, and again, foci are really hard to label here, so I'm actually just going to determine what the foci are and write them down here. So remember, foci for an ellipse are c squared equals a squared minus b squared, so 16 minus 4. So c is equal to the square root of 12. For an ellipse, the foci are in between the vertices and the center, but it's the center plus and minus that. Because this is oriented vertically, that would affect the y-coordinate. So my foci are the center, the x-coordinate stays the same, so -3. And the y-coordinate of 1, I would be adding and subtracting that c value to get the focus. So I've labeled the foci kind of off to the side because on here, also that's not a nice whole number. So putting it out here is actually preferred, okay? And vertices, again, if you're asked for those, these are kind of clearly marked at points. Okay, this is, remember, over 1. This is going to be opening vertically because a squared is under the y, and y came first, and this is b squared. So my center is at -4 is with the x, so -4, 0 for the y. All right, and then we have a is 4, b is 1. All right, so let's go ahead and graph these guys. So we've got our centers at -4, 0. It's oriented vertically, so we're gonna go up 4 to get our vertices, and down 4. And then right 1, left 1. Create the box. Okay, so I'm gonna draw my asymptotes from corner to corner. All right, and then this is oriented vertically, so my graph curve goes from the vertex between the branches, so it's kind of skinny. Okay, so things that are kind of hard to see here that I should maybe label off to the side are the asymptotes. So you can use the equation we learned, or you could just count, right? Rise over run. So to go from my center to the corner, I go up 3 and right 1, and then I go the opposite direction. So my slope is 3 over 1, but it could be plus or minus. So it is y minus the y coordinate of 0. So I can just do y. And then equals the slope plus or minus 3 over 1. And then x minus the x coordinate, which is -4, so plus 4. Okay, so there's our equations of asymptotes. Foci, again, I would need to know c. So c squared here is square root of 16 plus 1. So c is the square root of 17. Foci here, again, is affecting the y coordinate of the center. So my foci, the x coordinate of -4 stays the same. And then 0 plus or minus root 17 is where I would get the foci. So some additional things that are kind of hard to label on your graph that you still want to be able to find. All right, the other thing we need to be able to do is look at an equation and identify the type of conic it is. And we also need to be able to put things in standard form. Okay, so this says foci, so right away I know it's not a circle. And the vertex is -2, 1. So let's kind of just get a rough idea of where those are. So 3, 4 is a focus. 3, -2 is another focus. So this helps me find the center. So those are on the same vertical line. And they are 6 apart from each other. So 3 is going to be the center. So my center is going to have coordinates 3, 1. Okay. The vertex is at -2, 1. Okay. So this, you guys, the vertex should be at 3, 6. So if my vertex is at 3, 6, it's outside of the foci. So that only happens for an ellipse, right? The foci are outside the vertices for hyperbolas. So this is an ellipse. And it's oriented vertically, right? So A is that value. So from the center, so this, our center is 3, 1, up to 3, 6. So my A is 5. We don't know B, but we know C. Right, the distance from the center to the focus is 3. So then I can do c squared, so 9 equals a squared minus b squared. And then I can solve here. So let's see, we get -16 equals -b squared. So 16 equals b squared, and b is 4. So now that we have a, b, and c, we can write our equation. So our center, x coordinate, it's oriented vertically. So B is going to go under the x, which was 4. So 4 squared is 16. Y minus the y coordinate of 1. A is going under y, which was 5. So 5 squared. So there is our equation. Okay, this one is giving us asymptotes, so just because that, we know it's a hyperbola. Okay, so here my slope is -1 and 1, which just means A and B are the same, right? Because my slope I usually get from B over A or A over B, so A equals B, and then plus 4. So it's going through 4, my center is at 0, 0. Okay, so let's see what we got here. So 0, 0, and then I have a slope of 4. And this is kind of weird. I also, okay, so sorry, that's a kind of an ugly graph, you guys. So remember, the vertex then is going to open between the parabolas. So in the vertex, at 0, 0, lets me know kind of that my center has to be here if that's where those asymptotes are crossing. So that gives me my A value. So A is equal to 4, which means B is also equal to 4 because we established if my slope is 1, that A and B are the same. So then C, right, C squared is equal to A squared plus B squared. So C is then equal to the square root of 32. Okay, I guess I didn't really need to find that. I would need to find that if they asked me for the foci. They don't. I just need to write the standard form of the equation. So this is the center. Center is at 0, 4. And then we have everything else we need. So center is at 0, 4. So my x coordinate is 0. Oh, and sorry, I need the y to come first since it's opening vertically. So we're going to do y minus the y coordinate over a squared minus x, the x coordinate, over b squared equals 1. All right, this guy, if I look at x squared versus y squared, one of them's negative, so this is a hyperbola. X squared versus y squared here, we want them all on the same side before I compare, so we'll get to that in a second. Okay, I'm going to complete the square. Put the x's together, but I'm going to factor out the 4. Put the y squareds together, factor out the negative 1. Move the 8 over. And yeah, I'm taking up way too much spot. 4 times something minus 1 times something. All right. Here I have 4 times b over 2 is negative 1, squared is 1. B over 2 squared here is negative 2, squared is 4. Simplify by factoring. Over here we got 8 plus 4 is 12, minus 4, it gets us back to 8. Divide everything by 8. And there we have our equation in standard form. Okay, I'm going to move everything here over. So I'm going to add the x squared. So we got x squared. Sorry, I'm just going to do this down here, you guys. So I can kind of separate these two. All right, so we've got x squared plus 8x plus y squared plus 32y equals negative 263. Okay, so b over 2 squared is 16, so we're going to add 16 here. B over 2 squared, 16 squared, 256. Double checking my math. All right, so factor. Oh, sorry, and I forgot to compare. X squared and y squared were positive and both the same, so this is a circle. Okay, let's see, and then this factors to y plus 16 squared, and then simplify over here to get our r squared. So we got 256 plus 16 minus 263, so we get 9. So there is our standard form for equation of a circle. Okay, last one, we are given the center of a circle and a point on the circle. And we want to write the equation so it looks like this. So we know the center, and we know an additional x and y coordinate. So we're going to do x minus 3 plus y plus 1 equals r squared, but we're going to go ahead and plug this x and this y in. So we're going to do 7 minus 3 squared plus negative 5 plus 1 squared equals r squared. So let's see, we get 4 squared is 16 plus negative 4 squared, which is another 16. So r squared equals 32. So for my equation, I could do x minus 3 squared plus y plus 1 squared equals 32. All right, that's everything for this review video, guys. Thanks for watching.